Have you been breaking lots of rotor blades lately? Would you like to have a smooth flying helicopter like this one? Well, let's see what information Ed Nakasone has to share with us in this article about helicopter rotor blades.
Hi, this is Ed, Breaker Blade Nakasone again. How y'all doing out there? Glad to see you guys are, in fact, taking me literally and breaking a blade. As I indicated earlier, to achieve a smooth flying helicopter, one of the major requirements is to get a perfectly balanced blade. And that's what we're going to be covering today, blade covering and blade balancing. Before we begin, however, let me explain to you some of these blades that's on the market today. Here's a typical blade. This is a Schluter blade here, how it's constructed right out of the box here. What you'll find is a layer of hardwood material in the first half of the leading edge and on several layers of balsa material for the trailing edge. In addition to that, you'll have some hardwood material for your blade root, as well as a brass piece of material so you can hold your blades with your bolt here. Inspect the blades for any cracks along the way or any warps that you might have, as in this case here. If you do have a warp, obviously, take it back to the place you bought it from. Inspect the blades, like I said, for any chip. Here's an actual blade that was taken out of the box and cracked in this point here. Another one that is not common, but may happen to you as it did to me, is the length of the blade here. Make sure that they are, in fact, the same length. If not, again, return it back to your place of purchase there. As in my case, I've flown helicopters several years now, and I did have an accident whereby the blades actually flew off in flight. Now, to prevent that, Miniature Aircraft Incorporated has developed a new blade root that will prevent that. In this case, Mr. Sconard, the president of Miniature Aircraft, indicated that this particular blade will withstand up to 4,000 pounds pull here. That's tremendous. These blades come already slotted with weights so that you can, in fact, have a CG-corrected blade for any auto rotation process there. In addition to that, several fiberglass blades are on the market, as in this case here. This is a blade for the Heim helicopter here. It's a washout material with tapered. The washout tapered process there just provides an equal amount of force along the blades here. The only problem with this is it gets quite expensive. Materials on the market today for blade covering are somewhat similar to this, like this adhesive foil, which was developed by Mr. Dieter Schluter some years ago. Another one is this easy-to-use heat shrink material. The material we'll be using today is your basic white plastic adhesive that we will be referring to as the foil. Okay, as far as the tools are concerned, as you know, there's numerous tools and products on the market today to aid you in the proper balancing of the blades. These tools in front of me are just a bare necessity that I use and have been proven over and over again to aid me in, as far as achieving a perfect balance. Obviously, you need a sandpaper. I bought a 320 grit sandpaper to sand the blades down, a pencil for marking, and above all, a good sharp X-Acto blade, knife rather, several tools to lock down your blade on your blade holder, a measuring device. I use this 90-degree vise to mount my razor blade here to balance and find out where my center of gravity is on my blades. I use a clamping device to hold down my high pointer onto the table here. Now, the high pointer, I think, is a necessary item in achieving precise balancing of the blade here. I've modified mine whereby I could use a Heim main shaft, a 10mm main shaft, whereby I can just go ahead and put it in there. You noted that I've also have my Schluter follower, which will be mounted on the head, but this is the device I use totally to balance the head in its entirety. But to balance the blade, I got to insist that this is a clever device developed by Mr. Dieter Schluter, and it's sold to Roby Model Products, a blade balancer. It balances each blade relative to each other Now, as far as this yardstick is concerned, a metal yardstick, I use this to line up my rotor blades onto the head before I lock it up and balance it. This quarter I use to provide weight for my covering material during the covering process here. And finally, these blades will be going into the pre-balancing portion prior to covering the blades itself. I have a step that I include in here which is called pre-balancing and determining where the center of gravity of each blade is. I have no scale, therefore I'm utilizing the Shaluta blade balancer to accomplish this for me. Go ahead and slip the blades in here and determine which is the heavier blade. The purpose of this is to determine the heavier blade is to ensure that if there's any adjustments that we can have the light blade adjusted up to the heavier blade. Now we're pretty much in sync here, so take this off, place the other blade, and we're just, like I said, just relatively predetermining which is the heavier so we can make any adjustments if necessary. Here in this case we've determined that this is a lighter blade, so if there's any weights or any adjustments to be made, we'll bring the lighter blade up to the heavier blade, so I better mark that at this time with an H here to indicate which is the heavier one. Once I've determined which is the heavier blade, I'll go ahead and from the underside determine which is where the center of gravity of each blade is located at. Once it's balanced, I'll just go ahead with my palm, lightly press on it to get a line and mark it with my pencil at this point here. Same thing with the other blade. With my palm again, lightly pressing down on the blade, creating that line there, and I'll go ahead and mark it with my pencil. I'll go ahead and align my blades together to see how far apart my center of gravity is from each other. In this case, they're awfully close, off less than a millimeter. So the tolerance here is about 1 to 2 millimeter apart. Then everything should be in sync. And I also noted that the blades aren't too far apart from each other as far as their total weight is concerned. So at this point, there's no real major adjustments that is necessary on this particular blade set here. If it were off, that's when you have to either drill different holes to bring the CG into balance or the blade in balance together, or add in additional weights and or taking off weights. So that's the process we're looking for in the pre-balancing. Now everything is good, so we'll go ahead and cover the blades itself. Here's a diagram that I've drawn up here. The green depicts the rotor blades itself. What we're going to do, the black is the covering material. We're going to have a little lip here of about 1/4 of an inch on the trailing edge. Then come on up and just wrap the foil around the blades in this direction to the underside and finish up here. Okay, so we're ready to cover here. Let's get the foil out and take off the backing of the adhesive itself. Here again, I recommend that you lay this material on a flat surface and pull in the back because it has a tendency to wrinkle on you, and that wrinkle is very difficult to remove once placed in there. And discard the paper. Now, at this point I indicated I place about 1/4 of an inch to the underside of the blade, so I'll go ahead and mark it at this time here. So to cover the underside first, this is what we're going to do. We line the blades on top of these marks that the 1/4 inch marks that I just drawn on here with the blade edge to the far extreme of the foil itself. Then by gradually pressing down on the adhesive material, placing my 1/4 onto the adhesive material and sliding the foil out completely. At this point, what I'm doing is from the center, working out plastic foil onto the trailing edge. Like I indicated, this is a balsa trailing edge, so be very careful as you work on this. Note how the 1/4 is just hanging down there, preventing the material from folding over and sticking onto the blade. Another thing is that this hand is there to prevent the foil from wrapping around onto the blade. So work it on and be very neat and precise. I'll hold the blades in this manner here, and with my thumb working from the center, I'll go ahead and work all the bubbles and wrinkles out of the materials itself there. I'm sure you can see what I'm doing right here. And just gradually working it towards the leading edge. Working it out, ensuring that there's no bubble, no wrinkle. You don't have to rub it that hard. And that's basically what you have as far as the blade covering. Now that we got our blade covered, I've affixed this blade tracking material to each of these blades here. This is a critical moment now. We know that the blades are pretty much in balance to each other, but we need to make another final check to ensure that it remain there because due to the covering material that we utilized here. So again, you recall that we marked this heavy blade with an H here. We'll go ahead and get that thing balanced in first. Okay, it's good for close measures just to determine if we still have a light blade and a heavy blade. So let's check this out here. And yep, we still have a light blade here. So now let's go back and double check with the center of gravity or the CG of each blade, see if it remained the same. And we mark with our palm again. We'll do that there. We got a nice mark here. Same thing again. And a very quick check will indicate that, oh God, we're closer on the CG right now, so that's perfect. With that, we know that this is the heavier blade. We need to bring the lighter blade up to meet the heavy blade. Here again, it's just a trial and error process. Cut a strip of material. There's that sticky part of the adhesive part. Turn it upwards, don't stick it to your blade at this time. And remember where you had your mark of the CG, place that right over the center of gravity. We're pretty close here, awfully close. I call that great. The object here again is to ensure that we bring both blades into balance, and that'll be the key to the entire process. And here we go, wrapping it around and bringing it over and double checking it. That's great. See no problem here, it's super. We'll go back and double check the heavy blade. Well, it's not a heavy blade anymore because we've really pretty much balanced these two blades to each other. And with that, the true test again is mount the blade onto the hold system utilizing the high pointer. Now the final stage, as I indicated, was to mount everything on the head assembly and check it on the high pointer. Now this particular assembly was checked thoroughly, but before I begin, I need to explain to you that this particular head assembly belongs to the Shaluta Champion. As such, you'll note that the collective mechanism and the follower is offset on one side, thereby giving you a different ratio as far as the balancing of the head is concerned. To counteract that, I've added a aluminum wheel weight from your car on this side to keep the ballast equal on this head assembly itself. Note also that I've included every linkage that I can and just tied it down here on this 10mm shaft. Then of course I balance the head assembly without the blades onto the high pointer to ensure that everything is in fact in balance. Then I've added the main rotor blades onto the head assembly simply by ensuring that everything is aligned or parallel to the blade holder. Do the same with the other blade as well. From there, go ahead and mount your assembly in the high pointer, and if everything worked out in according to plan, you see that everything will pretty much hold in its way. Horizontally, check it out. Vertically, she should hold pretty good there. Do it on all 4 points here, and you'll find that everything is pretty much in balance here. And the ultimate test is to hold it at about a 45-degree angle. And if she's balanced perfectly, this is what you'll find here. Voila. 37, 38, 39, 40. Well, I guess this wraps up this portion of blade covering and blade balancing. So again, this is Ed, Break a Blade Nakasone for RC Video Magazine saying, happy flying, and don't forget, break a blade. 41, 42, oh hell.